Hello, everyone. This video is going to walk through our Chapter 5 quiz. Now, really quickly, we've taken the Chapter 5 quiz already. This video is not meant to teach you these subjects, concepts, I guess I should say, from 5.1 through 5.4. We've already had lessons on these. They're separate videos. You can go check those out if you need to. But this video is just going to walk through the problems, show you how to work them, maybe remind you of some concepts, and hopefully help you understand what went well, what didn't go well, and clarify any misunderstandings on this quiz. So problem number 1 was all about graphing, the graph of a parabola, of a quadratic equation. So it says, use the function shown to complete the table, find the y-intercept, and find the vertex. Graph the function below, fill in answers to the right. So whenever we are graphing a parabola, the first thing we want to start with is the axis of symmetry. And if you remember, the axis of symmetry is a vertical line, so it has the equation x equals negative b over 2a. So if you recall, a is the number of x squareds we have in our function. We have 1x squared, so a is 1. B is the number of x's. C is the constant, just that number there, so it's negative 3. So if I'm looking for the axis of symmetry, I can say it's x equals, start plugging in, negative my b value, which is 2, over 2 times a, which is 1. So x equals negative 2 over 2. Axis of symmetry is the vertical line x equals negative 1. Now, that's helpful for a couple reasons. First, it allows us to kind of get an idea of where our parabola will be. So I'm going to sketch just a dashed line there. That's our axis of symmetry, the center, if you will, of our parabola. But it also gives us kind of a foothold for how we find the vertex. Because if you recall, the vertex has to be on this line. It's the center, and the vertex is in the center of the parabola. So we know that the x-coordinate of the vertex has to be negative 1. All right, so negative 1 is the x-coordinate. How do we find the y-coordinate? We are just going to plug it in to our function. That's how we would find any y-coordinate. So f of negative 1 equals negative 1 squared plus 2 times negative 1 minus 3. I'll add those in red. And then I'll just go through and simplify. Negative 1 squared is 1. Minus 2 minus 3. F of negative 1 is negative 4. So that means our vertex is at negative 1 comma negative 4. And I can put that on my graph. So we have the vertex. We have the axis of symmetry. Go ahead and box the vertex. That's also going to be the center of my table. We talk about having 5 points. So I'm going to make negative 1, negative 4 the center. And just to remind myself, that's my vertex. So then to find the other points, I'm simply going to go, I'll go forward 2, back 2, that's a negative 3. And kind of like we did for the y-coordinate of the vertex, I can plug in any x value and find the y-coordinate on this parabola. So because these parabolas are symmetrical, I know that if I go 1 to the left at negative 2, it'll match 1 to the right at 0. So I really only have to plug one of those in. So I'm going to choose to go f of 0 because that's a really easy thing to plug in. 0 squared plus 2 times 0 minus 3. And I can see that's just going to equal negative 3. And again, because of the parabola being symmetrical, I know that if 0 is at negative 3, negative 2 is at negative 3. Then I ask myself, would I rather plug in 1 or negative 3? Personally, I would rather do positive 1. So f of 1 equals 1 squared plus 2 times 1 minus 3. 1 plus 2 minus 3, 0. 1 comma 0. That means negative 3 comma 0 is also there. 1 comma 0. negative 3 comma 0. And at this point, we have enough to freehand our parabola. I'm going to try to hit, oh gosh, I keep missing something like this. It doesn't have to be perfect. Something like that for our parabola. What's the y-intercept? It's where I hit the y-axis. It also, if you remember, is the c value because y-intercept is when x is 0, so I plug in 0. And so the c value was negative 3. That is my y-intercept at 0, negative 3. And then the vertex we already found, negative 1, comma, negative 4. So that's problem 1, all about graphing parabolas and finding some of those elements. Number 2, kind of similar, has to do with the graph. It says, determine whether this function has a maximum or a minimum, and circle your answer to the right, max or min, and then find that value. So the first thing we want to remind ourselves of is a is 2. We have 2x squareds. If a is positive, we're going to open upwards. If a is negative, we're going to open downwards. A is positive, so we're right here. And that means, sorry, I shouldn't have erased that just yet. All upward opening parabolas have a minimum value, a lowest point. We go up forever, so there's no max, but there's definitely a minimum, a lowest value if we're opening up. So I can circle minimum. You might recall that the minimum or maximum value will always be at the vertex, because if you look at the image I've drawn, of course, that's going to be the lowest point we see. So if I can find the vertex, the y coordinate is the minimum value. So where am I going to go with this? I'm going to say I need to know the x coordinate of the vertex. Happens to be on the axis of symmetry, negative b over 2a, negative 8 over 2 times 2. So that's positive 8 over 4. So that's where the axis of symmetry is. That's the x coordinate of my vertex. And so to find the y coordinate, because that is the minimum or the maximum, how high do we go, how low do we go? I'm just going to say, what is f of 2? F of 2 is 2 times my input squared minus 8 times my input plus 9. Two times 4 minus 16 plus 9. 8 minus 16 plus 9, which comes out to be 1. So what does that tell us? That tells us this point on this graph is 2, 1. And therefore, the minimum value, the lowest point we see on this graph is 1. That's my minimum value. You might also write, I'm okay if you write the full point. Technically, the minimum is just that y coordinate. But if you write the full point, I'm okay with it. So I'll say 2, 1, or just simply 1. All right, number 3 was kind of the final problem on here that had to do with graphing. It says solve by graphing, write your solutions as a set. And we haven't necessarily talked about the set as much, write your solutions. We won't worry too much about that. But remember, the solutions are wherever we hit the x-axis. So if we can graph it and find out where we hit the x-axis, we're in business. So again, this is a graphing problem. I'm going to start with my axis of symmetry. I'll label it axis of symmetry, x equals negative b over 2a, negative 4 over 2 times 1, getting my a, b, and c from the equation, negative 4 over 2, axis of symmetry, negative 2. I'm going to use that to find my vertex. Vertex is at negative 2, comma something. Let's plug it in. If I plug in negative 2 squared plus 4 times negative 2 plus 6, I will get what is the y coordinate at the x coordinate, negative 2. So That'd be 4 minus 8 plus 6, which is 2. So negative 2, 2 is my vertex here, which gives us something kind of interesting, which I'll touch on how you might know the answer at this point. But remember, the solutions are where we hit the x-axis. So I'm going to make a quick table. I know that negative 2, 2 is my vertex. So I'll go negative 1 and 0, negative 3 and negative 4. And my goal is just to keep going until I find something that hits the x-axis. So let's go with plugging in negative 1. So if I plug in negative 1, I will get negative 1 squared plus 4 times negative 1 plus 6. 1 minus 4 plus 6 gives us 3. And this right here should start setting off alarm bells, because it looks like we're opening upwards. Let's try one more just to make sure. If I plug in 0, 0 squared plus 4 times 0 plus 6 is just 6. And again, what's going on here? Because this is my graph. Where am I hitting the x-axis? Nowhere. Nowhere. So what are my solutions? There are no real solutions. There are no real numbers that can make this correct. We could also say the empty set, but we never hit the x-axis. Now, does that mean there are no solutions? We've actually learned since then that we could have imaginary complex solutions with i's in them. But as far as on this graph of real numbers, there are no solutions. That's where we sit. What about number 4? Number 4 says the sum of two numbers is 12, and the product of two numbers, same two numbers, is negative 28. Write and solve a quadratic equation to find the two numbers. Put your equation on the first line, your two numbers on the second. Gave you a hint, write two equations and use substitution. So first equation, sum of two numbers is 12. I'm just going to use x and y. Sum means atom, x plus y equals 12. Product of the same two numbers is negative 28. X, y equals negative 28. And I need to write and solve a quadratic equation to find those two numbers. It has to have an x squared in it or a y squared. So what I'm going to do is reference the hint. I wrote my two equations. I'm going to use substitution. I'm going to get y by itself here. Y is equal to negative x plus 12. And now let me substitute that into my second equation. X times y, negative x plus 12, is equal to negative 28. Well, let's go ahead and distribute. We get negative x squared plus 12x equals negative 28. That's a great equation. It could go on the first line. I'm going to put everything on the same side, make it equal to 0, because that's how we're going to factor this. So maybe I'll move it all to the right because I like my x squared's positive. Add the x squared, subtract the 12x, we still have minus 28. That is a fantastic quadratic equation. X squared minus 12x minus 28 equals 0. Quadratic, it has squared term, and it should represent kind of how we can find this x value. Once we know x, we can plug it in there to our half box to find y. So let's do this then. Let's think about factoring, because we've just learned how to factor to solve quadratic equations. What's the only way to get x squared? We're going to put x and x. I know my signs are different, plus and minus. And so I need two numbers that multiply to be negative 28, but add to be negative 12. And this might take a second to think through. 7 and 4, 28 and 1. but 14 and 2 is going to pop out. I'm going to make it negative 14 and positive 2 to make sure they add up to be negative 12. So I'm going to put the 14 over here, the positive 2 right there. Negative 14 and 2. Okay, so then what x values make this true? X could be negative 2 or positive 14. Those are the two possibilities for x that would make all this true. So what y values would go with them? Remember, we have our half box there. If x is negative 2, what would y be? Y would be negative 2, so positive 2 plus 12, 14. 14, not 12. What if I chose the other x value? What if I said, I'm actually going to keep 14 for x? Well, what would y be then? Let's plug it into our half box. Y equals negative 14 plus 12, negative 2. And you can see these are really the same two numbers. It just depends which one we call x, which one we call y. This problem asked us to find two numbers that multiply to be negative 28, add to be 12, and whichever one we call x, whichever one we call y, it looks like those two numbers are 14 and negative 2. And you can do a quick mental math just to check that out. Absolutely works. So this is kind of how we can use quadratics factoring to solve word problems like this. Let's go to the back page. The back page is just, it's lots of equations. We got complex numbers down there. But on this top part, we want to factor, solve. So this first problem, when we're factoring, we always want to make it equal 0. So I'm going to add the 13x over, subtract the 10. And it has a leading coefficient of 3. We have 3x squared. So how do we handle that? It's the one that's a little bit harder, but it's just grouping. So a times c equals negative 30. I need two numbers that multiply to be negative 30, add to be 13. I immediately see, so I could go 10 and 3, but it would have to be both positive. Well, one would have to be positive, one would have to be negative to multiply to be a negative. And I don't see how I can add them then to get 13. But pretty soon, hopefully I'm finding 15 and negative 2. Multiply to be negative 30, add to be 13. So those are my two numbers. So what do I do with these numbers in grouping? If you remember, we're going to keep the first term, we're going to keep the last term, but we're going to split up that plus 13x's into plus 15x's minus 2x's. Split up that b term into plus 15x minus 2x, and now it's time to group. What can I pull out of this first group of 2? It looks like I can pull out a 3x, leaving me with x plus 5. What can I pull out of the second group to make it match? It looks like a minus 2, leaving me with x plus 5. Yep, it matches. So then with the grouping, my two factors are the things I pulled out, 3x minus 2, and the things that were left inside, x plus 5 equals 0. Now, if this problem had simply asked me to factor, I would be done. It's in factored form. But this was an equation. I want to know what would make it equal to 0. So I need to say what x value would make 3x minus 2 equal 0? Well, 3x would have to be 2 then, which means x equals 2/3. And what about x plus 5? X would have to be negative 5. So my two x values, and again, don't worry about writing solutions as a set. I've updated these instructions. X equals negative 5 or positive 2/3. And we could check those by plugging them back into the original. So that was a grouping problem. Typically harder than just straight factoring. Straight factoring we're going to see on number 6. And I'm going to see if I can fit all the work just right under it because I used up all my room with the other one. First, make it equal to 0. X squared plus 4x minus 45 equals 0. Nothing to pull out, really. So I'll just set up my parentheses, my binomials. How do I get x squared? X and x. Two numbers that multiply to be negative 45, add to be 4. And again, thinking through it, 15 and 3, but then 9 and 5. 9 and 5, I know my signs are different. I want 9 and negative 5 because when I add them, I want to have more positives. I want to end up with positive 4. So I'm going to put the 9 with my plus, the 5 with my minus. And then what x values would make these factors 0? Well, negative 9 would make that one 0. X equals negative 9. And positive 5 would make that one equal 0, just kind of from inspection. What can I plug in to make that 0? So x equals negative 9 or positive 5. Similar problem on number 7. I'll do this one in green. X squared minus 16x will make it equal to 0. Plus 64 equals 0. Set up our parentheses. We know that x squared is going to leave us with x and x. I know that the signs are the same because this is a plus and they're both minuses. I can look back and see that. Multiply to be 64, add to be negative 16, negative 8, negative 8. So what x value would make this equal 0 if x equaled positive 8? And actually exactly the same for that one. So this is where we have a double root, one value that kind of accounts for two of the solutions, if you will, two of the roots. But we don't have to write it twice. We can just say the solution is x equals 8. Again, from factoring, we want to be really good, comfortable with factoring. All right, number 8. 5x squared plus 100 equals 0. I could factor. And that's not a bad thing to do to start off. I'm going to say maybe I can pull the 5 out. 5 times x squared plus 20 equals 0. So I'll start by factoring. Because it's an equation, I could divide that 5 out on both sides. So it's gone here. That leaves me with x squared plus 20 equals 0. And at this point, we're looking and we're like, okay, it doesn't seem to factor nicely. Let's maybe solve it using the square root property we've seen. X squared equals negative 20. Square root both sides. X equals plus or minus because it's a square root. And now I just need to figure out what is the square root of negative 20. Well, I know that I can pull an I out because of that negative. Remember, if we have a square root of a negative, pull the I out. So I pulled the I out and I'm going to say, can I break down 20? That's 4 and 5, 2 and 2. So I have a pair of 2s, 5 left over. I'm going to say x is equal to pull the 2 out plus or minus 2i with the 5 left inside. Plus or minus 2i root 5. And those will be our solutions for this quadratic equation. More practice with radicals coming up soon, but hopefully that's looking familiar. Again, we have learned this. This is just meant to show you how to work these specific problems, not completely teach the concept. Let's talk about number 9. 9 says, here are some roots. Write a quadratic equation. This actually has multiple answers depending on what you want your equation to look like, but here's how I would start. If the roots are 2/3 and negative 4, and we're told that, we're kind of going backwards from some of the previous problems. Let's look at green. Now let's look at blue. Blue, we found factors x plus 9 and x minus 5. And multiplied together, they equal 0. So x plus 9 times x minus 5 equals 0. We asked ourselves, what are the roots then? Whatever we can plug in to make those equal 0. Well, now we're going backwards. We're told what the roots are. So the question isn't, what can we plug in to make the factor equal 0? It's, what factors could we plug these roots into that would make the factor 0. And I think it's those two. If we plug 2/3 in here, we'll get 0. If we plug -4 into my x plus 4, we'll get 0. So we're working backwards from our factoring problems. This is technically a quadratic equation, but I'm going to multiply it out so it's very obvious it's a quadratic equation. I'm just going to FOIL. X times x is x squared plus 4x's minus 2/3 x minus 4 times 2/3, 8/3 equals 0. If you're not a huge fan of the denominator having the fractions divided by 3, multiply everything by 3. We can do that as long as we do both sides. Don't have to, but maybe it'll make it look nicer. So I'm going to multiply everything on both sides by 3. That would give me 3x squared plus 12x minus 2x's, get rid of that 3 on bottom, minus 8 equals 0. 0 times 3 is still 0. And then I'll just combine like terms. And now I don't have to worry about the fractions. 3x squared plus 10x minus 8 equals 0. And that's a fantastic quadratic equation. As I said, it could look a little differently, like if we didn't divide or multiply everything by 3. But that right there is a quadratic equation, has the x squareds, that has roots 2/3 and -4. And we kind of reverse engineered it. We started with the roots, we wrote the factors, then we made it look in standard form. Okay, handful more problems, all having to do with I. So let's start churning through these. Square root of -80, I know that I can write that as plus or minus I root 80. I can pull the negative out, it becomes an I, plus or minus I root 80. So then all I have to do is simplify 80. I know that 80 is 20 times 4, and that 20 is 2 times 10, and that 10 is 2 times 5, and that 4 is 2 times 2. So I've got a pair of 2's, I've got another pair of 2's. I can pull both of those out, so I get plus or minus 2 times 2 times I, because I had 2 pairs of 2's. That's why there are 2 of them out there. With a 5 left over inside, no pair. Plus or minus 4I root 5. There we go. Plus or minus 4I root 5. What about 11? For 11, we're going to make use of that radical property that says if we're multiplying a radical times a radical and they're both square roots, we can just multiply the insides and combine them under one square root. So -6 times -12, this is the square root of positive 72. So I'm gonna go through then and maybe break down my 72. That's 6 times 12, because I just multiplied them. That's 6 times 2, and I have a pair. So pair I can pull out. I'm going to say plus or minus 6 root 2. And you might have been wondering, wait, but we had negative square roots. Why wasn't there an I? Think about this. If we had written this as I root 6 times I root 12, we would get I squared, I times I, root 72. I squared is just a -1, remember. So -1 times root 72, and 72, not 27. When I break that down, I'm just going to get, again, 6 root 2. So I'll get -6 root 2. But remember, it's plus or minus. So it'd be like minus or plus. It doesn't change the end result. Plus or minus 6 root 2 here, whatever way you slice it. I to the 33rd. If you remember, I to the first is I. I to the second power is -1. I cubed is -I. And I to the fourth is +1. Excuse me. And we saw in class this repeating pattern. I to the 5th just loops back, I to the 6th, 7th, 8th, then we'll loop back for 9th, 10th, 11th, 12th, loop back. So one way to do this is to count out to 33, but here's what I would do. I to the 4th is 1. I to the 8th is also 1, remember. I to the 12th is 1. So any multiple of 4 in that power will give us 1. So I look at this and I say, well, this is I to the 32nd times I. That's my closest multiple of 4. I know that I to the 32nd is just 1 because it's a multiple of 4. I to the 33rd can be just considered I. And there we are. Number 13, complex number operations. Pretty easy if you know what you're doing, combining the real parts and the imaginary parts. I might distribute the negative. 6 minus 9i minus 17 plus 12i, and then start combining. 6 minus 17, negative 11, negative 9i plus 12i plus 3i. Not too bad. 2 more. 14, multiplying 2 complex numbers together. So 14, we're going to FOIL and then simplify, especially remembering that I squared is negative 1. So 7 times 8, 56. 7 times 4i plus 28i minus 24i minus 12i squared. So if we recall that I squared is negative 1, what we end up with is 56, I'll combine these two, plus 4i minus 12 times negative 1. Minus a negative 12 is basically plus 12, which means I can now combine that with the 56, the real parts. 68 plus 4i. Last problem on this quiz, dividing complex numbers. And if you remember, we can't have an I on bottom because I is technically the square root of negative 1. Radical, we don't want a radical on bottom. So what do? We saw in class, we're going to multiply by the complex conjugate of the denominator. 3 minus I, the conjugate is 3 plus I. And why are we going to do that? Because let's see what happens on bottom. 9 plus 3i minus 3i minus I squared. 3i and 3i are gone. We get 9 minus I squared, which we know is actually 9 minus negative 1 because we know that I squared is negative 1. We get 10 on bottom. Let's see what we get on top. 6 plus 2i plus 3i plus I squared, which again is negative 1. So 6 plus 5i plus a negative 1. We get 5 plus 5i. And then we're going to break it down so it looks like a good, well-formatted complex number. The real part, 5 over 10, plus 5 over 10i, the imaginary part, and simplify those fractions. 1/2 plus 1/2 I. So this video, walking through all of the chapter 5 quiz, hopefully, kind of taking the time through this helps you see, again, how to work these problems, clear up any misunderstandings that you might have had originally. It's a lot of work. Chapter 5 is one of the hardest chapters, if not the hardest chapter, because there's so much new and it's not easy. But I'm hoping that this video helps you out. If you have further questions on it, let me know. But that'll be it for now. Until next time.